Okay, so we're going to continue talking about the forces within the atom. And as we talked about briefly before, the two main forces we have strong, which are trying to pull particles together like two protons. And then in the opposite direction we have electromagnetic. And we often see electromagnetic abbreviated EM, like when you hear about an EMP, electromagnetic pulse, so like in the movie The Matrix, there's that. So EM, electromagnetic forces. And so when we think about this, what we can do is we can kind of graph these to show this comparison between these two forces. And so we make a graph. And so on the x-axis, our independent variable will use distance. And so when I talk about distance, what I mean is that if you have a particle here, proton, and another particle here, another proton, distance is this area right here, so the distance between the two particles. And so if we remember, we've got strong forces which are trying to bring them together. But then we also have the electromagnetic, which is trying to push them apart. Because two protons, two positively charged, the electromagnetic is trying to push them away. And so if we want to make a graph of the distance between these two, and then on the y-axis, our dependent variable we'll say is the force. So first of all, for strong forces, as we said before, close into the nucleus, much stronger, but they drop off very quickly. So what a graph of strong forces might look like would be something like this. You see that in close, with a short distance, very high, but as you start to move out, drops off very rapidly. So now in comparison, the electromagnetic forces, similar behavior. So for example, if you have two protons really far apart, there's not much of a repulsive force to them. But as you push them together, that force repulsing, trying to push them apart, gets stronger and stronger. And so what you see is that it looks something like this. So at short distances, it's always, in these shorter distances here, your repulsive force is always going to be less than that strong force holding them together. And that's why we have stable nuclei, plural nucleus, is because the strong force is greater than this repulsive force. But as you start to push those particles apart, eventually you will hit a point where that repulsive force, the force trying to push them apart, becomes greater. And then, since the strong force is less, those two particles, those two protons will stay apart. And so where this will really start to come into play is when we start talking about nuclear chemistry. And so kind of the two types of nuclear reactions. First is fission, where you're trying to split an atom. And so in fission, when you're splitting something, we're starting out here to the left, where you've got strong forces are in control. And what we're trying to do is, in this case, we usually slam particles in there to try and knock these two protons, or maybe protons and neutrons, but we knock these particles loose and we're trying to put enough distance in there that we get over this point here, where suddenly the electromagnetic takes over and they break apart. And so that's fission. And then the other side of nuclear chemistry is fusion. And that's where we're trying to join two particles. So you might be out here, two protons, and you're trying to force them together, slam them into each other, so that the distance suddenly becomes, so you get them over this hump, over this edge, and then you get them to stick together. A lot of energy involved in either breaking apart or joining them together. But we'll talk about that a lot more in the future as we get into nuclear chemistry.